Okay, so this is Cross Products Part 2 of a 3-part series. What we're going to do is I am actually on the 3rd page and I'm on Part B. So I'm on page 3 of Cross Product Notes, and once again I'm working on Part B. So like I said before, you can use the other method, but I'm going to use the basket weave method. So if you use the basket weave method, I'm going to go ahead and put up I, J, and K here. And then remember, we have to repeat I and J. Okay, so I'm looking at vector V, and I'm going to read off the coefficients. I have 3I, 1J, and 3K. So I'm going to repeat that. I'm going to put 3 and 1 here. And then I'm looking at vector W, which is 1I. I don't have a J, so I'm going to place a 0 in there. And then I'm going to put a -1 for K. So I repeat the 1 and the 0. Okay, now I'm ready to use the basket weave method. So I'm going to work on sum 1 first. So sum 1, I'm going to start with I and get J and K. So I'm going to go and change the color really quick. Just bear with me so we can see this a little easier. Let's use red. Okay, so I'm doing I first. So I'm working left to right. So I have 1 times -1, I, plus. Now I'm working on J. 3 times 1, J. And now K. Plus 3 times 0, K. Alright, so I get -J, sorry, that's an I, -I, plus 3J, plus 0K. Alright, I'm going to highlight that. That is sum 1. Okay, so let's work on sum 2. So this time around, I'm working right to left, so I'm going to do J first. So J is 3 times -1 plus I is 3 times 0 plus K is 1 times 1. Okay, so I get -3J plus 0I plus K. Okay, and that is the answer to sum 2. Okay, and I'm going to quickly check my answers. I'm going to pause it so you can check your answers too, and then I'm going to start up again. Okay, everything looks good, so now I'm ready to take sum 1 minus sum 2. So sum 1 was -I plus 3J plus 0K minus -3J plus 0I plus K. Okay, so I'm going to go ahead and I'm going to distribute the negative through the second one. So I get plus 3J minus 0I minus K. And then I'm going to combine like terms. So I have a -I plus 0. Sorry. So -I minus 0 is just -I. And then the J is the 3J plus 3J, that's 6J. And then 0K minus 1K is -K. Alright, so my result is -I plus 6J minus K. Okay, and that is the resulting vector of the cross product. Okay, so that one's done. Moving on, we're going to do this next example. It asks us to find vector V cross vector V, so it's crossing itself, if the vector V is -3I plus 3J plus 2K. So same process, I, J, K. Repeat the first 2 columns, I and J. We're going to put the coefficients down of V, which is -3, +3, and 2. So I'm going to put -3 and +3 here. And then I'm going to repeat those values again because I'm crossing the vector times itself. Okay, and now we're going to use the basket weave method. So I'm going to do sum 1. Sum 1, I start with I. So I get 3 times 2I plus j is 2 times negative 3 plus k is negative 3 times 3. Okay, so let's make this look better. We get 2 times 3, which is 6i. 2 times negative 3 is negative 6j. And negative 3 times negative 3 is negative 9k. Alright, so that's sum 1. So let's do sum 2. Sum 2, remember we're working right to left. So I do j first. So this is negative 3 times 2j plus I is 2 times 3 plus k is 3 times negative 3. So I get negative 6j plus 6i plus 9k. And that should be actually negative 3. Let me look at that in a moment. It's 3 times negative 3. This should be a negative 9. Whoops. Let's fix that. That's what I'm saying about checking stuff. This should be a plus here. Okay, so I have my 2 vectors. Let's go ahead and look at them really quick. We notice that the I components are exactly the same. The j components are exactly the same. And the k components are exactly the same. So when I subtract the 2, you're going to see that everything cancels out. Because this becomes 6i minus 6j minus 9k. Alright, and I'm going to take the negative sign through S2. So it makes all the signs different. So instead of a negative 6j, I have a positive 6j. Instead of a positive 6i, I have a negative 6i. Instead of having a negative 9k, I have a positive 9k. So what happens is everything cancels out, because negative 9k plus 9k is 0. 6i minus 6i is 0. Negative 6j plus 6j is 0. So when you cross a vector with itself, you get 0. That is the answer. Alright, we're ready for the next page here. So the next page talks about how we use cross products, what's some geometric properties of it. So recall from section 10.5 that 2 vectors are said to be orthogonal if they intersect at a 90 degrees angle. Additionally, we learned that 2 vectors are orthogonal if their dot product equals 0. So dot times itself equals 0. Now we're ready to learn something else that's kind of cool. The vector that results from finding the cross product of 2 vectors is orthogonal to both vectors. So we're talking about 3-dimensional plane here. So vector u cross vector v will give an orthogonal to both u and v. Okay, you guys can read through the proof if you want. Please do so on your own time. I'm going to skip through and move forward. And I'm going to really pay attention to the box down here on the bottom of page 4. So I'm looking at page 4 here, and I just highlighted what I'm looking at. Okay, so this orthogonal relationship is expressed in Theorem 8 in the box below. So additional geometric properties of the cross product are given as well. For instance, u cross v is orthogonal to both u and v. The magnitude of u cross v equals the magnitude of u times the magnitude of v times sine theta, where theta is an angle between u and v. The magnitude of u cross v is the area of a parallelogram. I'm going to go ahead and highlight that one. Having u not equal to 0 nor v as adjacent sides. And finally, if we cross U and V and it equals 0 if and only if U and V are parallel. Okay. Alright, so those are nice properties to know because we can use them to solve other things, and we use a cross product to get the job done. So I'm going to go ahead and start the last video. The last video is on page 5, and this will be part 3. So this is the end of part 2. Please watch the last one.